Okay, so last lesson, which was only the last 2 periods that we had, we learnt about the distributions that were in the tables, and we learned about expected values. We learned that if all of our scores have the same probability, what did we call them? Do you remember?
Standard.
Close.
Uniform.
Uniform. It was called uniform. You said it, did you, Ashton? Yeah. Good job. Uniform. Because they all have exactly the same probability, uniform, flat line basically. There was no variance, was a word that I kind of introduced there a little bit. Today we actually need to have a very detailed look at what variance is. Variance is measuring the spread of our scores. Okay, kind of like standard deviation, and we are actually going to be working out standard deviation as well. You'll see that down there in the list. But variance comes from, if we have our uniform distribution, what happens if we start to spread them out a little bit? Variance is measuring how spread out those scores are from our expected value. Okay, so you'll see a couple of formulas up here. It says here, the variance of a discrete probability distribution with numerical data is found using. The first formula there says VAR, that's variance of X, is equal to the expected value for variance will be each score subtracted by the expected value squared. Okay, that's what that first formula there is saying. Now, no, I don't think so. So what that is meaning, we take each, it's actually for the weighted mean, this is the one down here that we're going to be using in our table. Actually, I'll highlight one little bit at a time. We take each score, we subtract the expected value and square it. The reason we do that is for a couple of reasons. We need to know how much distance is between the score and the expected value. The reason we square it is because obviously some of them are going to have a positive distance and some of them are going to have a negative distance. And so we want to square it to obviously get rid of any negative signs. And obviously squaring it will also mean that any scores that are far further away are going to have a big impact as well, because squaring that difference makes it a lot bigger. Okay, so it helps to emphasize the variance in the score. Now, because this is going to be weighted, because each score does not have equal probability, we then need to times that by the P of X, so that we're weighting that variance according to the probability. And we will need to sum that for all of the scores that we have. Okay, so that is, I think, the logical way to work through what variance is. However, the textbook does require you to use this second version as well. It will ask you to use both types. And the second one, one bit at a time, we want to square the score and times it by the P of X, because it's really doing the same thing. That will give you the expected value squared, and then you'll need to take away the mu squared. Okay, and then sum the whole thing up. So that second formula there is known as the alternative formula. When you see that in your textbook, that's the form that it is talking about. On your test, you're going to have 2 of these types of questions. The first one very much leads you through to be setting it out for this first formula. The second one, the table is there. It probably is designed for you to do the second one because it doesn't have any headings there. You can put your own headings in there, but just based on the number of rows that it has there, it's probably more indicating that you should use the second method. But if you use the first one, it's fine, you'll get the same answer. Okay, so anyway, the first of each of the pair gives the best intuitive understanding of the variance. The second pair of each is usually easy for the calculation, because sometimes, especially with decimal numbers, it gets to be a bit of a pain to be subtracting them and squaring big long decimal numbers. Each difference between the score and the mu is the deviation of X from the mean. That word deviation, standard deviation, right? Okay, so every time you do a score, take away that mu, you're actually working out a standard deviation. So the standard deviation is a useful measure that we're already familiar with for measuring the spread of a data set. It is the square root of the variance, which I hope kind of also makes sense, because if a deviation is x minus 1 lot of your mu, we've squared that in our formula here to get variance, haven't we? So if we want to get rid of that squared again, we're going to have to square root it, right? So if you, in your tables, we'll be finding variance first. If you want to then find standard deviation, you will simply square root that variance. If there was ever a case where you did have the standard deviation, you would square it to get the variance, okay? The pronumeral for standard deviation is this one here, and the pronumeral for variance obviously has to be squared. Okay, so let's do some questions. Here is our table. Starts off very similar to what we were doing yesterday. It says a dice is thrown producing a uniform distribution. Find the mean and variance of the distribution using the formula. So it has told you which formula to use. It's the first one, the one on the left. And we have got our dice numbers there again, 1, 2, 3, 4, 5, 6. And we want to know the probabilities of each one. Okay, we did this multiple times yesterday. So the probability of each one of those is going to be 1/6. If you add up all of those probabilities, you're going to get a sum of 1. Good. The second row is x p of x. This is what we did yesterday. You're timesing the x times the probability. So 1 times 1/6 makes 1/6. Then the next one, 2 times 1/6 is 2/6. 3 times 1/6, 4, and 5. Makes it very easy just changing the numerator each time. Okay, I haven't even bothered to simplify my fractions there. When you add all of those up, that number at the end, 3.5. 3.5, you remember that from yesterday? Good job. Because we did this exact same question yesterday, 3.5 or 3.5. That box, I want to put a special colour around that because that is a very important number. What does that number represent? We worked out yesterday, it is the expected value. Okay, that's yesterday's lesson. That there is the expected value of x. In other words, that is the mu, or the weighted mean. Okay, so all of that what I've done, those first 2 rows, that was yesterday's stuff, finding the expected value. The next 2 rows have been added today because this is how we're now going to find the variance. So the next one, oh dear, my symbols have been changed. That should say there, does yours say a mu in there?
Yeah.
Good. So they should be mu's. So this next row, for each score, I want to do x minus mu. So x for this first one is 1, and I want to subtract 3.5. And then that's going to be in brackets squared. So if you have your calculator, if you type it in once, then you just move it along. You just have to change one number each time. You have to retype the whole thing. So it's going to be 1 minus 3.5, close bracket, squared. 6.25 for the first one. Okay, so then don't retype it. You just use your back arrows and change the 1 to the next score, which is a 2. So it's 2.25. Okay, and you go through and do all of them. I did all of mine as fractions when I did them. So my next one was a quarter, 9/4, and 25/4. Okay, just giving you those ones. I don't have to type all of them in. This last box here, put a little dash in it. I mean, we could find the sum if we want to, but it doesn't mean anything, so that box is not needed. We need to go on to the next row. So now I want to take x minus mu squared, that was this box, and I want to times it by the probability, which is that 1/6 there. So I'm doing 6.25 times by 1/6. Okay, so you do following exactly what the instructions say.
How many decimal places?
I left it as a fraction.
Okay.
So I got 25 over 24. Do you guys all want to try typing that in? Make sure you know how the process here. Or maybe do the next one since I told you that one. So the next one's going to be the 2.25 times by 1/6. What do you get?
3/8.
Yep, as a fraction, 3/8. Very good. Then a quarter times by 1/6.
1/20.
Yeah, 1/24. Liam, do you have a calculator? Or are you just distracting Senny for no good reason? Oh, you're sharing.
Yeah.
All right. So there are the rest of the numbers, like that. Now, then I do need that sum. This is the summing up of this one here. So all those numbers, add them all up across there. Give you all a second to try it. This is what you're going to be doing over and over and over in the exercise. Lots of calculating. Welcome to being a statistician. This is what you do, lots of calculating.
35 over 12.
Mixed numeral?
No. 2 and 11 over 12.
Yeah, that's what I had. So that number, put it in a big red box or something to make it stand out. That is your variance. So I'm going to call it V of X. There's my variance. So just because it's in a table there, I'm going to just write my answers underneath as well, because I was asked to find the mean. So the mean, therefore, the mean is another name for our mu, our weighted mean. That's what mu is. That was our 3.5, our 3.5. Our variance is the V of X, which was the 2 and 11 over 12. Okay? So that is using the first formula. Everyone's still frantically writing. The next question, we now need to go through a similar table, but note the table is different. This is to set us up for the second type of formula. Okay, so it says here, our die is thrown, producing a uniform distribution. It's the exact same question. Okay, it's the exact same dice. The probabilities are, again, always going to be the same here. 1, 6, 1, 6, 1, 6. With a sum of 1. And our xp of x, we already know that as well. You can copy that from the last table. 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6, which means that we get that 3.5 again, which is our expected value, or mu. So we now want to try and do the second formula, which means we need to find x squared p of x. So I'm going to take my x, which is 1. I need to square it, which is going to be 1 squared. So what you're putting in here is 1 squared, and you're timesing it with the probability, which is 1 over 6. So this 1 squared times that one is what that means. That will be equal to 1/6. Makes sense. 1 squared is still 1 times 1 over 6. So move on to the next one. I now want to do x squared, so 2 squared times 1 over 6, which is going to be 4 over 6, or 2 over 3, yeah. Now 3 squared times 1 over 6, 1.5, or 3 over 2. 4 squared times 1 over 6, yeah.
2 and 2/3.
Oh.
It doesn't matter if you're using improper fractions or mixed numerals, I don't mind.
Yeah.
Then we are going to have to add up that column. Okay, row, sorry, it's a row. Go across that row, add all of those numbers up. And you should get, as a mixed numeral, 15 and 1/6. That is not the variance though. Okay, what we have just found, this thing here, is expected value of x squared. Oh, that's a terrible x. Let me try that again. Okay, because the second formula, if I quickly scroll back here, this is the x squared p of x that I've just found, or expected value of x squared, and I'm to find the variance, I still have to subtract off my mu squared. Okay, so although it was only one extra column in my table, I haven't quite found the variance yet. There's one extra little bit to do. I'm going to write down the mean. I've already got the mean is 3.5. To finish my variance of x, you take that e of x squared, which was 15 and 1/6, and I have to subtract off mu, which is 3.5 squared. And you get 2 and 11 over 12. Is anybody surprised? No, because it was the exact same question, just done with two different techniques. Yeah? Okay, so be familiar with both of those techniques. Here is our 20 friends back at the Vietnamese restaurant. Same question as yesterday, but now we want to go a step further and we want to find the it says there we want to find the standard deviation of the distribution. So we know we need variance before we can work out standard deviation. So hopefully you remember this question. We had 20 friends there that all had different amounts of money that they'd brought along to the shop, and the robber comes in and stole somebody's money, and we worked out the expected value that they were going to get. So we had the probabilities. There was a 5 in 20 chance that they had $0, 2 out of 20 chance, 3 out of 20 chance. These you could read through if you'd forgotten these from yesterday. Oops, 2 out of 20, 3 out of 20, and 1 out of 20 for a sum of 1. Then we worked out the xp of x. This is all the expected value stuff. This is exactly the same as yesterday. So going 0 times 5 over 20 and then 50 times that to work out these numbers in here. So very quickly, because we've done this before, that's 0, 5, 9, 18, 15, 55.5 or 55.5, 23, and hopefully this number looks familiar, 125.5. Because that was what we worked out yesterday, was the expected value, which is the mu. So a thief coming in and randomly stealing someone's bag, taking off with their wallet, they would expect to get 125.5. Do you know what that means when they say expect? So that means if they were to do that same experiment over and over again, the average that they would expect to get would be that 125.5. Okay, so we now want to continue on to find our variance. This has been set up for the second type. You can see it here, the x squared p of x. So x squared means you want to square this one, and then you want to times it by the probability. So it's 0 squared times by 5 over 20. 0 squared, anything times by 0 is still going to be 0. Okay, that was an easy one. Then you want to do 50 squared times 2 over 20, which is 250. Yes, good job. Then the next one, 60 squared times 3 over 20. Yeah. You guys following along with this? Because I know I'm doing it reasonably quickly because I don't want to do every single calculation over and over again. Yeah, we're getting the idea? Yeah. So the next one, yep. Try typing a few of these in. Make sure you know how to get them. So you get 1620, 2250. They get bigger and bigger. 20535 and 10580. Now that's because when we sum that up, that's our expected value of x squared. So sum them all up. Is anyone doing it? Calculating frantically? Calculator's definitely your friend. Need them for this topic.
5,771.
Yeah, good. Okay, so just a reminder, that is not the variance because this is the second formula that we're using here. This is expected value of x squared. So to get the variance of x, you take that expected value of x squared, 775, and what do? We subtract the mu, finish it, squared. Got to square it. So minus 125.5 squared. Okay, that is 20024.75. Quite variable, quite big variance there. What is that as a standard deviation? Remember, the standard deviation is equal to the square root of the variance of x. So all I have to do is square root the 20024.75, and the standard deviation is approximately equal to $141.51. So that is the spread, the standard deviation. The spread is $141.51, which is about a mean of $125.50. Okay? So 13C, you're going to have to do lots and lots of these tables, so it will be a lot of tables to fill in. A lot of the first questions ask you to do, I think the first couple of questions say to use both tables. Do the same question twice, do it once with the first method, once with the second method. Okay? And lots of calculating.